Okay, so estimating a population proportion. Our assumption is that the sample is a simple random sample. That's the assumption for each one of these. The condition for the binomial distributions are satisfied, meaning fixed number of trials, 2 outcomes, success and failure, 1 trial independent from another, and then the probability of success stays the same. The normal distribution can be used as an approximation to approximate the distribution of sample proportions because our sample size is large enough. So the other requirement that we want to check is that NP is greater or equal to 5 and NQ is greater or equal to 5. So that's kind of our one additional requirement over here in order to approximate it. And usually as long as our sample size is large enough, that's going to be met. So 829 adult Minnesotans were surveyed, and 51% of them are opposed to the use of photocop for issuing traffic tickets. Use these survey results. Find the margin of error E that corresponds to a 95% confidence level. So our calculation for E includes that critical value, so the Z alpha half times the square root of P hat times Q hat divided by our sample size. Okay, so what's our critical value for a 95% confidence level? Yes, it's 1.96. We found that last time, right? So just to remember, over here we have our normal curve. We have our middle, which is the 0.95. That leaves us 5% in the 2 tails, or 2.5% in each. And then when we find these critical values, we're looking in Chapter 7 only for the positive one. So we have to add our middle area and our left area together. And then use the inverse norm of 0.975. And that is equal to 1.96 as we found last time. Okay, so critical values 1.96. Remember these critical values. These are values that separate our likely from unlikely values. So when we first talked about, unlikely or unusual values, we said anything that is more than 2 standard deviations away from the mean. Right? Then we looked at z-scores and we said any value that's greater than 2 or less than -2, those were unusual. So now depending on our percentage, like whether it's 95% or 90% or 99%, those numbers vary a little bit, but they're going to be pretty close to 2. So in our example, it's 1.96. That's the number that goes with 95%. All right, so what is P hat in our example over here? .51. P hat is our sample proportion, which is the percentage, just changed to the decimal numbers, so 0.51. What's Q hat? Yeah, 1 minus 0.51, which is 0.49. And then all that divided by our sample size, which is 829. Okay, so let's calculate this. So we have 1.96 times the square root of 0.51 times 0.49 divided by our sample size of 829. So we have a margin of error of 0.034. And, maybe let's carry a couple extra decimals. For our proportion, we're going to round our confidence intervals to 3 decimals. That's only for proportion. So because of that, and it's 3 significant digits, so we don't really know how many decimals we need. Maybe, 3 of them are going to be enough, but maybe we need a 4th one. So let's take our P hat and subtract the margin of error. So this is our margin of error, which was, that's what was the first part of our question. Later on, when we look at different types of questions, sometimes this margin of error is given as a percentage. So if I ask you what's the percentage or what's the margin of error given as a percentage, you just change that to 3.4%. So we want our results, our results are going to be within 3.4% of our sample proportion. So let's subtract 0.51 minus 0.03403, and we're also going to add it, and then we're going to round it to 3 significant digits over here. So 0.51 minus, and I'm lazy, so I'm just going to copy it down here, is 0.47597 and so on, and I'm going to round it to 3 decimals, so that's 0.476. That's the lower number, and then 0.51 plus this number is equal to 0.554. So our lower interval is 0.476. Our upper is 0.554. So I can now say I'm 95% confident that the true population proportion is between 0.476 and 0.554. So meaning if I took 100 samples from the same population, 95 of them would include that population parameter, and then 5% would not. Okay, just to show you guys how easy the shortcut is, we're going to do the same question, but this time we're going to use our shortcut. So on your formula sheet in the back, it says use the 1 proportion z interval. That's the one we use for proportions. And then we're going to look at what are the requirements that we need over here. So the way you get to these tests and intervals is by clicking on stat, arrowing over to tests, and then go down to, or down or up, I think up is actually faster, to 1 proportion z interval. A. And then you're going to follow the prompts over here. It says what is x, what is n, and what's the confidence level. So what does x always stand for? Okay, and remember we have a binomial distribution. X is the uh, 829. Who thinks x is the 829? The what? Okay, what is the 829? What variable is that? N. That's our sample size, okay? That always stays the same. X always means, for the binomial distribution, X is going to be the number of successes. Right? We have, we're going to multiply. So in order to find our X, we're going to do 0.51 times 829. So X is the number of successes, which is equal to N times P hat. So sometimes we have X given in the question, and sometimes we have P hat given. If we're trying to find P hat, that would be the number of successes divided by the total. So these two formulas, which are basically the same formula, are important. When we're doing it manually, our manual calculation has a p hat, but when we're using the calculator, we need the x. Now, one other thing, it says 422.79 people out of the 829 people are opposed. Binomial distribution, we're looking at whole number solutions. So what do you think, if I just leave it like that, what is my calculator going to say? Error. Okay, so I have to go in there and I have to change it to a whole number. And I'm going to just round it to the next to the closest whole number, which is how much? Yeah, so let's change it to 423. 829 is the total. Our confidence level is 0.95. Let's calculate it. And over here we have a lower interval level of 0.476, an upper of 0.554. Maybe I made a mistake there. Okay. 544. Somewhere I made a mistake when I entered it or when I wrote it down. So really fast, you guys, you can you just figure out what your X is, what your N is, figure out that you're looking for a proportion, which usually is pretty clearly stated. And then over here, then we're going to use that to make a conclusion. So the last question says, based on the results, can we safely conclude that the majority of adult Minnesotans oppose the use of the photocop? So over here, between 4.7, we're 95% confident that the true population proportion is between 0.476 and 0.544.
Would that be majority?
Well, what is the majority? The majority is more than 50%. So are we pretty confident that it's more than 50%? How? 50% is right in the middle here, right? So meaning, smack in the middle pretty much. So it could be less, it could be more. So are we confident? If I asked you like a question, are we pretty confident that more than 40% of the people? You could look at that and say, oh, we're pretty confident that it's between 47.6 and 54.4. So yes, we're pretty confident that it's more than 40%. But to say the majority, where the majority lies right in the middle of our confidence interval, we would have to say no, right? Maybe it's more, maybe it's less, or, we don't really know, because it's right in the middle of our confidence interval. So there's not a whole lot of conclusions we can do from the confidence alone. Chapter 8 will give us clearer conclusions. We'll be able to make a clear decision based on the numbers we get. But this is all we can do here. So what I want you guys to do is do a couple of these on your own. So you're going to turn to page 2 of the other handout and do a couple confidence intervals. Now pay attention whether you have a percentage given, which is like the p-hat, or a proportion given, or do you have an X value, a number of successes given.